Welcome to this tutorial. In this video, I'll be explaining regression analysis with respect to forecasting. Forecasting is basically the ability of predicting what the future would look like. Okay, so here I have with me a question which usually comes in the exam in global operations concerning regression analysis, where we need to develop the regression equation, or what is actually said to be the least squares equation or least squares line. Okay, so with me here I have a regression equation scenario where we have got the year and the demand, and then the examiner basically asks us to determine the least squares equation or the regression equation, as the case would be. And then secondly, the examiner would ask us to predict for period 8 or whatever period he wants us to predict. So we'll be looking at two variables in this instance. We have the x variable and the y variable. We'll take the period, which is the year, as the x variable, and the demand as the y variable. And the x variable is said to be the independent variable, and the y variable is said to be the dependent variable. Okay, so x, let me pick them quickly. I have 1, 2, 3, 4. Have you seen the years here? The years are continuing there: 5, 6, and 7. And then I'll have the y, which is the demand: 74, 79, 80, 90, 105 there, 142, and 122. So the first thing I'll do basically here is to find or to predict or to develop the least squares equation, which is the regression equation, which is given by the formula y is equal to a plus bx. So I need to calculate my a and I need to calculate my b. The formula for calculating b is given by n summation xy minus summation x multiplied by summation y over n summation x squared minus open brackets summation of x, and then we square it. So now this simply entails that I need to have xy here, because I'll need the summation of xy, and then I need to have summation x squared. So I need my x squared here. So now I have xy, I'm just multiplying the x and the y. This multiplied by that, 1 multiplied by 74, that would be 74. 2 multiplied by 79, that will be 158. Then 3 multiplied by 80, that will be 240. And then 4 multiplied by 90, that will be 360. 5 multiplied by 105, this gives me 525. And then 6 multiplied by 142, I have 852. And then 7 multiplied by 122, I have 854. All right. And then I need my x squared. 1 squared is 1. 2 squared is 4. That's 9. This is 16, 25, 36, and then is it 49? Yes, 49. Alright, so now I'm adding everything here so that I can have their sums, so that I can call them as summations. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, that gives me 28. Okay? 74 plus, 79 plus, 80 plus, 90 plus, 105 plus, 142 plus, 122, I obtain 692. Uh, 74 plus, 158 plus, 240 plus, 360 plus, 525 plus, 852 plus, 854. I get 3063. Okay, let me just do a quick run. Okay, absolutely correct. So let me add these guys here. 1 plus 4 plus 9 plus 16 plus 25 plus 36 plus 49. I have 140 here. Now I can slot these guys into the formula. N is the number of elements. There are 7 here. So I'll say 7 multiplied by summation xy. Summation xy is that guy there. So I have 3063 minus, okay, and then summation x multiplied by summation y. Summation x is 28. Summation y is 692 over n again, which is 7 multiplied by summation x squared. Summation x squared is that one, 140 there, minus summation x, which is 28, and then I square it. Let's see what we obtain here. I'll do the top part first, open brackets, 7 multiplied by 3063, close brackets, minus open brackets, 28 multiplied by 692. So the top part I have 2065. The bottom part, again, open brackets, 7 multiplied by 140, close brackets, minus open brackets, 28 squared, I have 196. And then I can finally have my B, 2065 divided by 196. That's giving me 10.54 to 2 decimal places. That's my B. Alright? Now I've calculated my B here. I'm going to calculate my A. A is given by summation y over n minus B summation x over n. Now you see the reason why we cannot begin calculating the A before we can get our B is because the B is part of the formula for calculating A. Alright? So now here I have summation y. Summation y is 692. So I have 692 over n, which is 7, minus B, which is 10.54. 10.54 multiplied by summation x. Summation x is 28. 28 over 7 here. Let me process that quickly on the calculator. So now we have 692 divided by 7. That gives me 98.86. Then 10.54 multiplied by 28 divided by 7. I have 42.16, and then that 98.86 minus 42.16, I have 56.7. All right. So now with this, I can now come up with the equation itself, which is y is equal to a plus bx, all right? And then y there, I was putting the values. A is 56.7 plus my b is 10.54 x, and then that's the regression equation or the least squares equation as demanded in part A of the question. Part B or part 2 is asking us to forecast. When we are forecasting, we just basically pick the same equation. We want to forecast the demand for period 8. Now, if you observe, the periods are the ones which I said I'll make them x. So if the periods are x, where there is x there, if we are forecasting for period 8, I shall put 8 on the x there. I have y is equal to 56.7 plus 10.5. Instead of saying that, I shall put 8 on x there. So BODMAS takes a preeminence here. I'll begin by multiplying there and then I'll add. So 10.54 multiplied by 8, I obtain 84.32 plus 56.7, I obtain 144. So y is equal to 141.02. This is basically the demand for period 8. All right. So this is a simple regression equation, but there is, however, a multiple regression equation. In global operations, the examiner does not stress you to begin calculating the A, the B1, the X1, and the B2 and X2 for multiple regression equation in global operations, but usually he will give you the model so that you look at the model itself and then you just fuse in the values for A, B1, X1 plus B2, X2. That is multiple regression equation. So the first thing he will give you is the model there. So we have the model there, and then he says Y is actually the value of sales in $1 million. And then we have the A, which is the constant here, 188. And then we say plus, and then B1 and X1 are given as value of sales 0.3 and $600 million. So I have 0.3 here multiplied by 600 there, and then here I need to be careful. As you can see there is a plus there, but B2 and X2 is interest paid, and interest paid basically reduces the sales value. So I need to put a subtraction here, even if the model which was given by the examiner is plus there, because interest basically reduces what? Sales. So I'll put the negative there to indicate that this is going to reduce the sales. So we have got 500 there and 0.12 respectively. All right? And then I'll process this in the calculator to determine the sales value. I have 180 plus open brackets 0.3 multiplied by 600 close brackets plus open brackets minus open brackets 500 multiplied by 0.12, and then I obtain 300 as my final answer. So therefore sales value is $300 million. All right. So this is what is basically expected of you to do under regression analysis. Thank you so very much.